Look up at the night sky. You see stars, planets, galaxies, a dazzling display of light. For centuries we believed this visible universe was all there was, but the cosmos hides a deeper truth. Most of it is invisible. Everything we see, stars, planets, gas, dust, makes up less than 5% of the universe. That means 95% is missing from our view. This unseen majority is made of two mysterious things: dark matter and dark energy. They don't shine or cast shadows, but they shape the universe on the grandest scales. Our familiar universe is just the tip of a cosmic iceberg. The quest to understand these invisible forces is a journey into the unknown, challenging our senses and our science. We're explorers at the edge of a vast, uncharted continent, just beginning to map its outline. The clues are faint: gravitational pulls, cosmic pushes. But they tell a story of a universe bound and driven by the unseen. This is the greatest detective story in science, one that could rewrite our understanding of space, time, and reality. The cosmos is calling us to look deeper, beyond the light. Let's begin our journey into the invisible universe. What keeps galaxies together? It's not just the stars and gas we see. When we measure how fast stars move in galaxies, especially at the edges, they're moving too quickly to be held by visible matter alone. They should fly off, but they don't. Something unseen is holding them in place. This was our first clue. There must be extra mass, invisible but powerful. We call it dark matter. It doesn't emit, reflect, or absorb light, completely invisible. We only know it's there because of its gravity. Dark matter acts as the cosmic glue, holding galaxies and clusters together. We see its effects everywhere, in galaxy rotations, in how clusters bend light from distant objects, a phenomenon called gravitational lensing. The mass we measure from these effects is much greater than what we see. Dark matter outweighs normal matter by about 5 to 1. Imagine a vast, invisible web stretching across space, with ordinary matter gathering in its densest knots. Galaxies form and evolve within these halos of dark matter. Without it, the universe would be a diffuse cloud. No galaxies, no stars, no us. Dark matter is the hidden framework of the cosmos. If dark matter holds the universe together, dark energy is pushing it apart. For decades, scientists wondered if gravity would slow the universe's expansion or reverse it. The surprise? The expansion is speeding up. Something is acting like anti-gravity, stretching space itself and driving galaxies apart faster and faster. We call this force dark energy. It's a property of space, a kind of energy that grows as the universe expands. Picture galaxies as raisins in rising dough. The dough expands and the raisins move apart. Dark energy makes up about 70% of the universe's energy. Its discovery means the universe's fate is likely a cold, lonely future, with galaxies drifting ever farther apart. Dark energy is the dominant yet least understood force shaping our cosmos. The hunt for dark matter began in the 1930s with Fritz Zwicky, who noticed galaxies in clusters moving too fast for their visible mass. He proposed dark matter, but his idea was ignored for decades. In the 1970s, Vera Rubin and Kent Ford found that stars in spiral galaxies moved too quickly at the edges, clear evidence of massive invisible halos. The discovery of dark energy came in the late 1990s. Two teams used supernovae to measure cosmic expansion, expecting to find it slowing down. Instead, they found it was speeding up. This shocking result turned cosmology on its head. The leaders of these teams won the Nobel Prize for revealing the universe's accelerating expansion. These discoveries opened a new era in our understanding of the cosmos. How do you study what you can't see? Scientists use clever indirect methods. For dark matter, they map its gravitational effects with telescopes, watching how it bends light from distant galaxies. Underground, sensitive detectors wait for rare collisions with dark matter particles, WIMPs. At particle accelerators like CERN, physicists try to create dark matter in high-energy collisions, searching for missing energy in the aftermath. Studying dark energy is even harder. Astronomers mapped the universe's expansion with ever greater precision, using telescopes to track millions of galaxies and supernova. Missions like the Nancy Grace Roman Space Telescope will help chart dark energy's influence over time. By building detailed maps of the cosmos, scientists hope to uncover the true nature of these invisible forces. The search is painstaking, but every clue brings us closer. The universe's secrets are out there, waiting to be found. We know dark matter and dark energy exist, but their true nature remains a mystery. For dark matter, the leading theory is WIMPs, massive particles that barely interact with normal matter. But decades of searching have found nothing, so scientists consider other ideas like axions or even new laws of gravity. Dark energy is even more puzzling. The simplest idea is Einstein's cosmological constant, energy built into space itself. But calculations predict a value vastly larger than what we observe, a huge problem for physics. Maybe dark energy is a changing field, or maybe our understanding of gravity is incomplete. Proving any theory is incredibly hard. The effects are subtle and vast. We need precise measurements of the universe's expansion to solve these puzzles. For now, the universe keeps its secrets well hidden. Why chase these invisible mysteries? Because they make up 95% of reality. Understanding dark matter and dark energy is key to knowing the universe's fate and our place in it. The search drives innovation. We build the most sensitive detectors and powerful telescopes ever made. This quest pushes science forward, inspiring new technology and training future generations. Every great discovery in science has changed our view of the world. Learning what the universe is really made of could spark the next revolution in physics. So next time you look at the night sky, remember, the real story is in the darkness between the stars. Imagine the invisible web of dark matter holding galaxies together. Think of the mysterious energy pushing them apart. The cosmos is a grand mystery inviting us to explore and ask big questions. The answers are out there, waiting for us. The greatest discoveries are yet to come.